complete genome of a type of rickettsia that essentially seems to live inside the tick and apparently doesn't seem to cause any problems for the tick. This is early days, we don't know. But there are relatives of this that cause things like Rocky Mountain spotted fever and typhus and things like that. So we've done a very interesting comparison between this organism. And interestingly enough, the tick is the vector for some of the rickettsia diseases that humans suffer. So what's this guy doing? What's this guy's role in this integrated system? And so this is an example of a genome that was essentially assembled without ever culturing the organism from a study. To get to diseases, we need to go through physiology and metabolism. It's kind of sad now that the general state in microbiology is that everybody became a molecular biologist, and so we have very few physiologists left. But that's, of course, where all the interesting phenotypes are. But we can build now metabolic models we have over 2,500 genomes from the data. And then we will allow people to play with these models. People trying to do things like build drugs and vaccines really need this. We, of course, hope ontologies will help us. We try. We wish there was a way, we've tried, to make an automated submission pipeline for genomes to NCBI, for example. We understand this is a hard problem. The main problem is that over 50% of all bacterial genomes that are being sequenced, at least in the US, are not being deposited because it takes too much effort to deposit them, and now it's too little effort to sequence them. So a couple of questions, a couple of points about designing for different user. For those of you who come from, this is the typical interface my people want, my